Greetings, in our The Most Scientific podcast, me, Alexander, physics researcher, and Crina, wine enthusiast, and she's also interested in science.
Yes, and today we're going to speak about the latest Nobel Prize received, why people actually hate it, and who received it, what is the winter of artificial intelligence, and all the steps of it.
Nobel Prize.
Nobel Prize, which is the latest Nobel Prize that was received actually in physics.
The latest.
The latest, yeah.
The latest was the craziest one. It was for the neural networks.
Oh, interesting.
The most important part of physics is neural networks, and so many people were butthurting because of that, because they're like, is it not even physics? Because, I'm going to shop and I'm getting some device which is AI powered, and it's usually marketing. They hate in everything which has AI, and then Nobel Prize in Physics, which is actually considered as the most noble one. It's kind of, you can get literature politically motivated, you can get the peace politically motivated, but physics was always like the most important, and now it's kind of suffering from marketing.
But why it was actually given for physics? How do you explain that?
I can joke about, I can say you seriously. The joke is for what then? For literature because of ChatGPT, or for peace because it's widely used in military applications? For what then? Basically, it could be given for mathematics, but there is no Nobel Prize for math.
Interesting. Why?
There is a joke like wife of Alfred Nobel was cheating him on some mathematician. But ChatGPT told it's a fake.
Interesting. Nice. But yeah, so there's not Nobel Prize in math.
And basically physics is quite natural because it's given to physicists who contributed a lot. They kind of brought their own basic research to the something which was neural networks in those times, and they basically did a lot of contribution to the current state of the situation. So basically it's given for their contribution of physical methods to the neural networks. We will discuss which exactly a bit later when we will go to this topic, but the idea is that.
Okay, then tell me the names of the ones who just started it. Let's go from the beginning.
It was Hopfield. The very, very beginning.
Yeah.
Not the winners, I don't remember their names.
They're dead already.
When I was digging into the topic, it was Frank Rosenblatt and one more guy who was listed in the Nobel Prize review. I'll write his name on the
over here.
Over here, both the names and portraits. And the idea is following. Those two guys somehow contributed to the very, very basic. Because in 50s, the first idea how the brain is structured appeared. And then they're like, okay, there is neurons. And neurons are somehow connected with each other. And the structure of single neuron is also quite easy. You have multiple inputs. You have one output. If the total excitation via inputs exceeds some threshold, it passes the excitation further to the following neuron. And it is easy to write mathematically. You just have a sum with some weight coefficients, and you compare it with some bias. If it's more, it's on. If it's not, it's not. Super easy, and it's easy to calculate. And even if you make a neural network of them, so if you have one output goes to input of following, it's super easy to write mathematically. You have just input and then matrix. And matrix is super easy for all kind of computers. That's it. And they were so excited, like, okay, now we will reproduce the brain. Now we will do ChatGPT, translations, everything like, And they failed. Because now you have, that's a typical joke, or not joke, it's typical true, that your phone has billion times higher computational power than the guys have had when they grounded on the moon.
At that time, yeah. So it was like around 1950s, right? Like when they started.
It was 50s, 60s, but those times the computational power was crucially lower. It was just funnily lower. So they had no chance to make ChatGPT. ChatGPT could only appear nowadays because it's a terabytes of data. It's like hours, month of computations.
Yeah.
And only then ChatGPT had appeared. Earlier, it just couldn't be learned. Probably it's impossible. They have had computer of like bytes. Like, I have computer with 100 bytes. Wow. And now I bought 10 terabyte HDD just to keep my photos.
So it was the main actually barrier that stopped them from researching.
Yeah, because even if they would make some network, they would not be able to like use it. There are no computers for that. Actually, there was a second reason because it was massively pushed by this Frank Rosenblatt, and eventually he died. And he was one person who pushed. All the others were like, idea is good, but we have no computational power. And the winter of the artificial intelligence has begun.
So romantic.
Winter is coming.
Yeah.
White Walkers or?
Yeah, I think so. Okay, so this guy died.
Yeah, this guy died, but people basically got disappointed. And you know how the science works. Unless you're making some promising expectations for people who have money.
So they give the funds.
No funding, no research. I mean, I would not say it was not completely stopped. People continued to develop, but there were no massive project. And there were two guys who were quite interested. Hopfield, John, if I'm not mistaken, John Hopfield, he could somehow contribute to this field. Did I fail? John?
I will see afterwards. Like, please leave it in comments. Like this we will remember.
Please correct me each time I fail the name. We will have a ton of comments.
Oh, yeah. So they just counted, like in school, like we were doing. We had like just out of topic, we had a math professor and he was having this thing, like he was saying da. Like yes after each sentence. Yeah, and we were counting like how many times he would say like during one lecture. Okay, so this dude, what did he do?
He did some theoretical physics, and he suddenly found that the math beyond neural networks and his field is similar. And I told you, just have multiplication of the metrics with the data. And he also has had this in his Hamiltonian, whatever it is for you. Don't want to explain. But basically, it looked exactly the same. And for the neural networks, during teaching it, you have to somehow minimize something, some error. And when you have some media, the Hamiltonian of the system also must be minimized. And you're like, wow, let's try.
Interesting.
And basically, what has he done? He found the similar physical system. It's basically a system of spins, which basically works the same. And he could implement the simplest neural network he couldn't personally, but he wrote math, and his experimental colleagues have done it somehow in the experiment. And what did they do? They implemented it somehow in the, not really hardware, but in the physical system. And it's, I guess, still called Hopfield network. I guess if you study in some introduction to the neural networks, the Hopfield is one of the names you met exactly right after Rosenblatt.
Okay. So they're the main first creators.
I would not say he's creator, because there were many people. If you look... if you look to the report of the, not report, how it's called, scientific basic of this Nobel Prize, you would find so many names, and always this guy and colleagues, many people. So Rosenblatt, bright name, this Hopfield is bright name, and then there was Hinton, Frank, if I'm not mistaken. So what did he do? He also theoretician, and he did some thermodynamics, and he brought the approaches from the thermodynamics again to this math, neural network math. I honestly tried to figure out what it is, even though I'm doing physics, I have no idea. He kind of brought Boltzmann blah blah blah, whatever it is, but it's basically from the statistical physics. And it helped in the figures they have shown. It means that they somehow rearrange the structure of the neural network. Because before, all the neurons supposed to be connected to many neurons around. And he told like, no, we have layers, and neurons within layer must not be connected to each other, only connection with the previous layer, with the following layer. That's from the...
So the structure, actually, yeah.
And some other mess, which I did not understand. And this, I told you from the nice picture, I guess we will place it, from the Nobel Prize report.
Oh, nice. Okay. It's always going to be here, over here. Yeah, because like they said, it's not nice to show it with your fingers. So, okay. Tell me about the biggest applications.
The biggest applications nowadays are surely ChatGPT, generative, blah, blah, blah. For example, I laugh in Photoshop.
Blah, blah, blah. Yeah, that's not an example.
I mean, when you, in Photoshop, you have a photo, I will just make a screenshot of us. Then I will remove you because of this question.
I knew it, like you're going to remember all the bad jokes and then like do something, mean to me.
Okay, I will remove myself to do not like...
And there's gonna be a voice still speaking, and I'm like they're like crazy. Yeah, that's an idea. Okay.
Actually, so that's basically the nowadays application. That's again why it has changed our life some. When you make a selfie, in Snapchat, when you make this face masks. Now you see how helpful artificial intelligence is. So don't forget to like the video and subscribe our channel.
Oh yeah.
I guess it deserves Nobel Prize.
For peace. It drains you from stress, probably. I don't know what
that's for nowadays. But the most tricky was those guys have developed. There was winter of AI.
Yeah.
And at some moment they brought, the computer developed, if in 60s it could not be somehow done, then in 20 years already, in 80s, it was already sufficiently better because of, this more slow, kind of each 2 years you have double faster computer. Now it doesn't work that way, but 10 years you have already multiple times better computer. And then was a question, because the area was not yet developed that good, but it was promising. And there were, I know 3 good examples where did it really appear, where it could bring some sufficient profit. Surely it was banking. It is very known data set for handwritten. I only now realized handwritten digits.
Yeah.
It's super ancient, and I only now understood it's the first data set was used for handwritten digits recognition in when you write the bill.
Yeah.
In the bank, it has kind of accelerated operations with the bills. Yeah.
Damn it, that's so long ago.
Yeah, cool. 80s. Yeah. And it's kind of a business application, and simultaneously there was there are 2 basically physics which produces a lot of data. It's accelerator physics, or how it's called, particle physics. When you scatter billion of particles per second, then you record billion outputs of the detectors, and then you get a lot of data. You have to somehow classify it, find which exactly data you would want to look at, because most of that is just garbage. And another is astrophysics. During night you make a lot of pictures, whatever it is, and then you have to somehow operate to at least look not at all the data, but at the needed data. And they use the application, it's really for recognition some patterns. That is the most important function of the neural network. It recognizes patterns. And the trick is, if you want to compare one photo and another photo, okay, it's my friend, and again, photo of my friend. But if you want to recognize, for example, if it's dog or not, this funny photo where muffins and Chihuahua.
No.
I will place the photo, and you really cannot distinguish if you swipe them rapidly. Yeah. You will never distinguish if it's muffin or Chihuahua.
Okay, so it's kind of a dessert or something? Okay, yes.
Chihuahua is a dog, muffin is a dessert.
Oh, thank you. That was mean.
Yeah, actually, I mean, recognition itself is very tricky because, I mean, to recognize Chihuahua is stupid, but if you have X-ray and you want to recognize if this person has some inflammation or not, if there is a traces of cancer, like a doctor could fail. But the fail is very worthy. You would pay a lot if you fail. Then you somehow employ here already neural network, which accelerates, which like says, okay, pay attention here. And it is so important. And it all has appeared at the moment people started to recognize some patterns, handwritten patterns and some patterns in data as like from accelerator.
Okay, and also like it's important, I think, to mention that when you have multiple photos, how does it actually influence, right? What it is giving it to us.
So what's the idea? If you recognize one-to-one photo, that is a tricky because like you compare one Chihuahua and another Chihuahua, they are actually different dogs. But then you send a huge data sets of photos to your neural network, and it somehow in brain averages the data and makes an imaginary like Chihuahua or a dog, and then compares not to the certain photo but to the some imaginary, some averaged. And it works actually as for child. So you show to child like, oh, it's a dog or it's another dog. But basically some different, some bulldog and Chihuahua, they're that different. You would even not consider them as the same species. And neural network, you can teach as a child and say, okay. And it recognizes with crazily precision.
Okay. So it's also like consuming less time in this case. And I remember in the beginning you're saying that you have some examples how it is being applied, also like in your daily work.
Yeah. In my daily work, there are two good examples. One of them exactly as a pattern recognition. So, for example, we develop at work TMDC. I guess we will discuss it in one of the following videos because it's a very promising material, way better than graphene. So don't forget to subscribe us to do not miss this material. It must be probably following Nobel Prize. What's the application? How this TMDC is done? We have a substrate like a few square centimeters of silicon, and we attach a crystal onto. Attach a crystal, then kind of exfoliate some flakes. And the flakes are of 25 microns roughly on centimeter square. It's very tough to spot them because they are tiny, they are almost transparent. And we tried to push a student to do this work, but he told like, it's crazily, you just sweep, look, nothing is interested, you just spot coordinates, and then they are different. They are single layer, double layer, 3-layer, multi-layer. You also have to distinguish them. And here exactly the pattern recognition approach is very important because you can get rid of the stupid work. You can just automatize the sweep among the sample, and then you just at the end getting coordinates of the proper flakes you need. Like if you need the flakes with single layer, you're getting coordinates of them. That's a direct approach, but here you use it as a tool. In physics, there are two, I would say, at least two very meaningful approaches. For example, you can replace the solver of the partial differential equations. So differential equations are very, very important in physics. You basically, so all the physics, all the serious physics after school is written in terms of differential equations. And to solve them, it takes too many times. So basically, on the paper, you can solve them for exclusive cases like for sphere. Therefore, you have the spherical horse in vacuum. And very known meme. If you, by your face, I see you do not know this meme.
No.
Like spherical
It's
horse
too
in
deep into
vacuum.
the physics.
Okay.
You'll show it to me later.
I will show you the meme.
Here.
Okay. probably in the next video we will just be recalling some memes and showing them here.
Yeah, like when there's the weather forecast, right? Like over there is gonna rain, here is gonna be this thing. I don't know why I'm saying it with this accent. Okay.
We need a green screen.
Yeah.
So partial differential equation. And basically neural network can solve it. Not with that high precision as the standard method to solve it, which is called finite element method, which is also base of our life. And the idea, the solution will be not certain. And physicists, they can do the most unique stuff in the world, but they're so conservative in approaches, they do not believe to this method. And in the fact it works, some can accelerate some calculations. For example, if you like make some preliminary study, you can use neural network because it speeds up your calculations, and then you already verify it with the trusted method, for example. And it is also like a tool to improve, because you could do without. And there is the only one, for my actual opinion, the most important stuff that you're getting from artificial intelligence, data science, in the physics itself, and engineering especially. That's an inverse problem. Have you heard about?
No, but you're gonna tell me. So what's the inverse problem?
There are many design problems. For example, you have a microphone or you have guitar. You want to have it with a certain characteristics. And you only can get the characteristic when you already develop the design. And from design, you somehow recalculate those characteristics. For example, the spectrum of like how the guitar will sound. You when you first get a draw, then you get a model, and or if you make really an example, you solving kind of direct problem. But there is an inverse problem. When you actually can from the spectrum get the exactly shape of the guitar you need. And without neural networks or all these artificial intelligence approaches, you would never solve the problem. It's just impossible. You would, in the classical approach, you get a guitar with some characteristics. Then what you do? You think, okay, if I modify it this way, I would get it better. And then you make a new one, calculate, blah, 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 and then you vary, you can vary so many parameters of the guitar to make it perfect, and you waste it many times. But the approach here, you make some samples. You can model them in advance, then you study neural network with those parameters. And then you just write a spectrum or like some characteristics as you in generative neural network, like I want to have a cat.
Yeah, it's giving you the...
And generative stuff exactly works in this way. Then you draw what you want to have, and it gives you shape. And the shape is sometimes so sophisticated you would never figure out it in advance. It is crazy sometimes.
It's actually solving the main problem.
It is solving. Yeah. Sometimes it's unsolvable. Sometimes it's complicated to solve. I tried to implement it to my work, and with first 2 attempts, I failed completely. But I know it's basically solvable. I will try more. And I, for example, have seen excellent example. So usually if you want to split colors kind of into rainbow, you have a periodic stuff like periodic rating 150 up to like 1000 lines per millimeter, and then it gives you a rainbow. But for standard case. But if you have a fiber which has a size of, I don't know, a few microns, and you want to build in some structure which would split it from one fiber into 3, you would never come up with the idea how to implement it. And I will show here, surely, the image.
Shall I help you?
Yeah. Thank you.
Pleasure. I always dreamt of doing that. Yeah.
So, and it looks completely unpredictable. It looks like just a crazy, like now if I just have some beans, I have just thrown them on the floor somehow, and it splits colors into 3. It splits into those exactly 3 colors, which are even not visible, into 3 channels. Somehow you would never make, like from the direct task, It's just
something like-
unsolvable.
Yeah, so for the human brain, it's really impossible.
I don't know for human brain, for engineers' brain.
Yeah, that's still a human brain. Or
Yeah, probably for human brain, probably even for physics itself.
Yeah.
Like it's tough to solve from the direct problem, but you can't do inverse problem. I guess it's the most fascinating, most crazy application.
and the most scary one.
Yeah.
A bit.
So
Because you have an artificial intelligence doing it actually for you. For me, it's still like why? Because I have a similar kind of. I had a similar talk with an IT guy, and he said like it is doing for him sometimes parts of codes, right, and the coding part, and I was like, whoops.
yeah, it's about to replace me.
Yes. But as you said, yeah, it's fascinating as well because this is saving a lot of time.
It will never replace me because most
It
of
doesn't have a heart.
no, because it cannot stressfully procrastinating and drinking coffee.
Only coffee, come on.
At work, mostly coffee.
Ah, okay. And some tea.
Yeah. So basically, I guess now you see that, first of all, neural network is really helpful and it can somehow help us. It not only supports you to recognize like where is muffin and where is dog, but it helps you with like, for example, in medicine, it recognizes if there is a cancer, if you have to pay attention to this person exactly, or it can solve inverse problem. There are many, and memes, neural network memes. You don't know them? I will.
No.
My favorite, the cat is sitting and it's like spotted in the square and the dog, and it's kind of, oh, I have no fear that neural networks rebellion will ruin us.
Oh, that's cute. Yeah, nice. And after everything you said, especially because of the winter of AI and all the steps that were done, I think I would actually give that Nobel Prize. If I could, I would, even before.
I guess the trickiest moment, because there are so many people who contributed, the trickiest, why exactly to them? And why exactly
now?
Nobel Prize? Why now? I guess now it's clear because ChatGPT and everything, like when I'm editing photo, I must not use this selection tool. I just click select subject and it's done, and saves so many time in my life.
Yes, and also it's an additional motivation, let's say, for also artsy people.
I guess for everyone, it just a tool.
I'm just like into that field somehow, so that's why I'm saying it.
I mean, in any application, it's just a powerful tool for.
Yeah.
Surely it will replace some person who has spent his life selecting something on the photo. But for artists who use it as a tool, like, I know, you remember that people were scared, like, oh, now photo camera is released. We don't need any painter anymore. Now photo is one industry, painting is another industry.
Yeah, because also like they changed through, like from realism to impressionism and so on.
Yeah,
And also there is an example of an artist who actually uses the AI, and then from whatever she gets the result, she's adding her details to this picture. So she's painting it from the picture from the AI and adding her part.
so many applications.
Nice.
So my point, I am not sure if exactly those guys deserve Nobel,
Yeah.
because online everyone is like criticizing. That's the most like discussed Nobel
Topic.
Prize.
Yeah.
My former supervisor called me recently, and he was on the conference of physics
Yeah.
this very day when this Nobel Prize was announced, and they
It was a
were
boom.
like, yeah, so many physicists and everyone like, what? They're like, no idea, just no idea. No
So
idea.
what do you mean by actually asking what? They were happy, they were not happy.
They just did not get, because it's physics, it's
Yeah.
neural network.
if you watch this video until this point, it means that you most probably liked it. So, like this video, follow us, and leave a comment. Where do you think we were right, or we were right, or not? I'm kidding. So, please, be active. Let us know what do you think about it, what we should change, maybe.
Where did we fail? Point it out.
Yeah, as well. I don't think we did.
Let them try.
Okay, yeah, that's true. And as well, here you'll see other links. Some of the links of, over here, of my Instagram and other channels where I speak about wine, about wine tastings, and about art. Please follow those ones too.
This channel is the most scientific channel, but there is the most academic channel. Here we discuss the science, some effects, some phenomena. And the second channel is about academic life, how to write paper, what's a peer review. Did you know? There will be a video soon.
Yep.
Moreover, since I'm a researcher, I do physics, there is a Telegram and Instagram channel where I say, what do I do by research? What's the first device I'm switching on in the morning when I am in the lab?
The coffee machine.
Exactly.
And then it's like, oh, time to go home.
Thank you for watching.
Yeah.
And don't forget to like.